Cooking is more than a mix of ingredients and heat. It's a symphony of chemical reactions that define flavors, textures, and aromas. The chemistry of cooking delves into these reactions, uncovering why foods taste the way they do and how various techniques can alter or enhance flavors. Let's explore some key elements in the science behind cooking. 1. Maillard reaction, the browning effect. One of the most important reactions in cooking, the Maillard reaction, occurs when amino acids, from proteins, and reducing sugars react at higher temperatures. This reaction is responsible for the browning of meats, toasted bread, and caramelized onions. Beyond color, it creates a complex mix of flavors and aromas that we associate with grilled, roasted, or seared foods. 2. Caramelization, sweetness and depth. Caramelization, another browning reaction, happens when sugar is heated. At around 320 degrees Fahrenheit 160 degrees Celsius, sugar breaks down, forming new compounds that add a nutty, sweet flavor and a deep amber color. This process is essential in making caramel, but it also happens in roasted vegetables and toasted nuts, giving them a rich, sweet taste. 3. Emulsification, blending oil and water. Emulsification is the process that blends oil and water into a smooth mixture, as seen in sauces like mayonnaise or vinaigrette. Chemically, emulsifiers, like lecithin in egg yolks, act as bridges, allowing two otherwise incompatible liquids to stay combined. The stable texture of an emulsion makes flavors linger on the palate, enhancing taste. 4. Acid and alkaline reactions, balancing flavors. Acids, such as vinegar and citrus juice, brighten flavors, while alkaline substances, like baking soda, can make food taste smoother or more bitter. These chemicals affect the structure of food at a molecular level, softening meats in marinades, for instance, or helping baked goods rise. The pH balance in food also influences texture and how flavors are perceived. 5. Hydrolysis and gelatinization, starch and protein transformations. Hydrolysis is a breakdown of large molecules, like proteins or carbohydrates, into smaller units. Cooking meat in water, for example, breaks down collagen into gelatin, making it tender. Gelatinization, on the other hand, happens with starches. Think of boiling pasta or thickening sauces with flour. These processes change the texture of food, transforming raw ingredients into tender, chewable dishes. 6. Enzymatic reactions, unlocking fresh flavors. Raw ingredients, especially fruits and vegetables, rely on enzymes to unlock flavors and alter textures. For example, enzymes in fruits can cause them to ripen or brown when exposed to air. Knowing how to control these enzymatic reactions helps in preserving food's freshness and taste. 7. Umami, the fifth flavor. Umami, often described as savory, is the fifth taste alongside sweet, sour, salty, and bitter. It's most commonly associated with glutamate, a naturally occurring amino acid in foods like tomatoes, mushrooms, and aged cheeses. Cooking enhances umami through processes like fermentation and aging, enriching the overall flavor profile. 8. Heat and flavor release. Cooking at different temperatures affects how volatile compounds, those responsible for aroma, are released. High heat cooking releases intense, fast flavors, while slow cooking allows flavors to meld and deepen over time. Heat can also reduce bitterness, soften acids, and intensify sweetness, allowing for a balanced and flavorful dish. In summary, the chemistry of cooking transforms simple ingredients into delicious meals. Understanding these reactions gives chefs control over flavors, textures, and aromas, enhancing the dining experience. Next time you cook, remember, you're orchestrating a complex series of chemical events, each step bringing you closer to the perfect bite.